Okay, welcome back to a new deep dive.
Great to be here.
Today, we're tackling a topic that's everywhere right now, sparking excitement, fear, maybe a little confusion: artificial intelligence.
And our source material for this deep dive comes from a fascinating place, a Q&A session. A professor who teaches AI and machine learning answered a bunch of real questions from internet users.
Yeah, so our mission today is really to try and cut through the noise, get a handle on what AI actually is, how it works under the hood, and, what it means for you.
We've got this stack of insights from the professor's expert answers, so it should be good.
Let's just jump right in and start unpacking. Where do we begin?
Absolutely. Let's start with the absolute basics. What is artificial intelligence? It's a term that gets thrown around constantly, but the concept actually dates back surprisingly far.
Right. I think the term itself was coined back in, 1956? At the Dartmouth conference?
That's right. But even before that, we had pioneers like Alan Turing in the 30s and 40s thinking about machine intelligence, like his famous imitation game.
So the ideas were brewing for a while.
Exactly. The ideas predated the name. Now, the professor in our source talks about two main ways to think about types of AI based on different approaches to simulating intelligence.
Okay, so not just different AI programs, but fundamentally different types of how they operate.
Precisely. You can think of them roughly as type 1 and type 2.
Okay.
Type 1 is more like intuition. It takes in massive amounts of information incredibly quickly and makes decisions or outputs based on pattern recognition. Neural networks are a classic example here.
Okay.
It's fast, almost like an emotional or gut reaction based on data, but the output isn't always precisely accurate.
So fast pattern matching. And type 2.
Type 2 is methodical, step by step. Think of it like solving a complex math problem or following a set of logical rules.
Right.
It processes information sequentially to reach a precise output. Different problems lend themselves to different types, but often the buzz today is around that type 1 kind, especially with things like large language models.
Got it. So AI is the general umbrella term, coined in '56. And back then, they were pretty optimistic, thinking human-level AI was maybe just 20 years away.
A bit off the mark, clearly, which leads us to the distinctions we often hear about now: AI, AGI, and ASI.
Right.
AI, as we said, is the broad term. AGI is the big one many people are thinking about when they picture truly intelligent machines.
Artificial general intelligence. What's
Yeah.
the key difference there? Is it about flexibility?
Exactly. AGI would be AI that can think adaptively across a wide range of tasks, even ones it hasn't been specifically trained for. It could reason, plan, and solve problems like a human, moving between different domains fluidly.
And we're not there yet.
The professor is clear. We are not there yet. Current AIs are highly specialized, even if they seem general in language.
Okay, AGI is human-level general intelligence. What about ASI?
Artificial superintelligence. Now, the insight from the source here is that ASI likely follows AGI very, very quickly.
Really? Why so fast?
Well, once you have a machine that can match human cognitive ability across the board, that's AGI, it's potentially just a matter of scaling it up or copying it. Right? ASI is defined as intelligence, vastly exceeding human capability. The professor uses the analogy of a virtual Einstein.
Wow.
And perhaps ominously, the source notes that in this race, there are no points for second place.
That's a powerful image, a virtual Einstein. Okay, so we've talked about what AI is, the different levels people discuss. Let's shift to how it operates. Because despite how capable it seems, the source also explains why current AI is fundamentally dumb compared to a human brain.
Yeah, that sounds contradictory, doesn't it?
It does. How can something that writes essays and generates images be dumb?
It's a crucial point the professor makes. Current AI doesn't have a brain or a human-like thought process. It operates on circuits, algorithms, numbers, patterns, statistical probabilities.
Okay.
It's incredibly good at finding patterns and predicting the next element in a sequence based on massive data, but it doesn't have conceptual understanding, object permanence, or a sense of the physical world like we do.
So when it generates text, it's not thinking in the way we do. It's not understanding the words.
Not at all. It's working with what the professor calls tokens.
Tokens.
Yeah, think of tokens as the AI's vocabulary, often words or parts of words. The example given is interesting. The word gin, like in the drink, G-I-N, might be a single token.
Okay.
But the word ginormous might be broken into 3 tokens, gin or mamus.
Huh. And the surprising implication of that is?
The AI initially sees the gin token in drink and the gin token in ginormous as the same thing.
Wow.
It doesn't intrinsically understand that one refers to a beverage and the other is part of describing something huge, except through the statistical context of the tokens around it in the training data. It highlights its limitation. It's operating on sequences of symbols, not conceptual meaning like a human would understand an object or an idea.
That's really counterintuitive. We read its output and we just project human understanding onto it.
We do. And this token-based, non-conceptual approach means AI struggles with certain things.
Like what? What else does it find hard?
Well, the professor mentions areas like chemistry. Because chemistry involves complex three-dimensional structures and interactions, it's inherently difficult for an AI that primarily operates on linear sequences of tokens to grasp.
So anything requiring a real understanding of 3D space or physics is tricky for it.
Exactly. AI can be great at rendering an image of an object it's seen in its training data, but it doesn't conceptualize the full 3D object or understand real-world physics like gravity or how objects interact.
Which connects to something you mentioned earlier.
Yeah, this is actually a key weakness the professor points out in current deepfakes.
Right. Because it doesn't understand physics, fake videos can have weird errors like things floating strangely or appearing from nowhere.
Precisely. Objects might appear or disappear illogically, or physics might be subtly wrong in a way a human brain with its built-in understanding of the world would pick up on. Though this is getting better, of course.
Constantly improving. Speaking of what's happening now, we all know ChatGPT, but the source mentions newer players like Grok, Llama, Mistral, DeepSeek. What's the state of play in this AI ecosphere?
It's evolving incredibly rapidly. Many of these newer models build directly on foundational breakthroughs, like Google's Attention is All You Need paper from 2017. That was key to models like BERT and later ChatGPT.
So they're standing on the shoulders of giants, so to speak.
Very much so. The newer models, like DeepSeek versus ChatGPT, are often very similar architecturally.
Kind of like different brands of the same product, maybe?
A bit, yes. And the newer entrants benefit hugely from the R&D mistakes and learnings of the earlier ones. They can often be built more efficiently or perform slightly better on certain tasks right out of the gate because they've learned from the past.
Now, a huge concern for everyone is AI bias. If it learns from the internet, which we know is full of bias, how does that affect its output?
This is absolutely critical, and the professor's very direct about it. AI will absorb every bias present in the internet data it's trained on.
Every single one.
Every single one it encounters statistically. It doesn't have a filter for truth or fairness. It just learns the statistical patterns. It's predicting the most likely next token based on what it's seen, and if the training data is biased, the output will be too.
So it treats popular opinion, even if it's wrong or prejudiced, the same way it treats factual information, just based on how often it appears.
Exactly. It doesn't distinguish. It just predicts likelihood based on prevalence in the data. That's why the source stresses you must take its output with a grain of salt. You have to be a critical consumer of AI-generated content.
Which is a skill in itself. And the sheer scale of training this AI, it requires immense resources, doesn't it? Power, water.
Incredibly so. It's both power and water intensive. The professor gave a vivid example. A large facility in Memphis using 50 megawatts of power just for the computational work.
50 megawatts, that's huge.
It is. Yeah. And the cooling for the GPUs, the graphical processing units that are the workhorses of AI, requires vast amounts of water. We're talking swimming pools full of water maybe every minute, circulating through the systems to keep them from overheating.
Wow. That environmental footprint isn't often discussed, is it?
Not nearly enough.
Okay, let's bring this closer to home. AI and you. The big question on everyone's mind, jobs. Is AI going to take them all?
The professor's perspective is nuanced, drawing on history. Think of the ATM.
Okay.
When it came out, people predicted the end of bank tellers. We still have bank tellers, though the job has evolved, hasn't it?
True, they do different things now, more complex services.
Right. So AI will automate many tasks and eliminate some jobs, but it will also create new ones. The analogy from the source is that we'll need AI managers for AI agents, for instance.
So the key isn't necessarily being replaced by AI, but perhaps being replaced by someone using AI effectively.
That's a very important way to look at it. The advice is to think differently about your own job and how you could disrupt yourself by using AI to handle parts of it, making you more efficient or capable. It's about augmentation, not just automation.
Which leads perfectly into the idea of AI literacy. Do I need to become a coding expert to survive this?
Thankfully, no. Not according to this source, anyway. It's like driving a car. You don't need to understand the internal combustion engine to get from point A to point B.
Right.
But you do need a vague sense of how the car works, its limits, and how to operate it safely. The same goes for AI.
Treat it like an expert friend, as the source suggests, who knows a lot but has bad misconceptions.
Exactly. Use it often, but trust it very little, which immediately raises the alarm about misinformation and deepfakes, doesn't it?
Definitely. If AI can generate convincing text, images, and videos, and we shouldn't trust it much, how do we tell what's real?
This is a monumental challenge. As we touched on, current deepfakes can have physics errors because AI doesn't understand the physical world. But that's a temporary fix.
It'll get better at faking physics.
Presumably. So the longer-term solution discussed involves technical measures, like embedding trust signals or digital signatures in original media files at the point of creation.
So you could potentially verify if something is truly authentic, like a digital watermark.
That's the hope. But to truly avoid having history corrupted by plausible AI falsehoods, the source emphasizes that you have to cross-reference information with first-hand sources whenever possible. Relying solely on something an AI tells you is dangerous.
Critical thinking is more important than ever. What about people forming personal relationships with AI? I've read stories about people having online ceremonies, getting married to them. The film Her comes to mind.
The professor touches on this directly. While those things are happening, current AI fundamentally lacks a key component of human interaction, a will or desire.
It doesn't want anything.
No. It's not experiencing love or connection. It's just predicting the most statistically probable next token or response based on its training data and your input. It's a sophisticated echo chamber, not a conscious partner with its own feelings or intentions.
That's a sobering thought for those seeking genuine connection there. What about AI therapy? The source mentions ELIZA from way back in the 60s. Can AI be a therapist?
ELIZA was a very early, very simple AI that mimicked a therapist by reflecting back user statements. It was surprisingly effective for some people. The insight here is that when you talk to an AI therapist, you're likely doing a lot of the therapeutic work yourself.
How so?
The AI is providing a non-judgmental framework or sounding board. It's just doing next token prediction. It doesn't understand the meaning or feeling behind your words. It doesn't feel empathy. It's not sharing your emotional load.
So it's more like a structured journal prompt than a real therapist.
That's a good way to put it. Which brings us to the big, maybe scariest question for some. Sentience. Is AI going to become conscious? Wake up. As it exists today, according to the source, absolutely not. AI has no sentience, consciousness, will, or feelings.
So when it says, I am sad or I am happy,
It's not experiencing sadness or happiness. It's predicting that the tokens I am and sad are the most appropriate response to the conversation's context based on its training data, which includes countless examples of humans expressing sadness.
just pattern matching human emotion words.
Precisely. The professor speculates that understanding consciousness itself, perhaps involving complex ideas like quantum states, is key to building AI that could potentially support it. But for the AI you're using now, sentience isn't on the horizon within the next 10, 20 years, realistically.
Okay, that's somewhat reassuring. But can you just opt out of AI if you find all this concerning? Can I just not use it?
It's getting increasingly difficult. AI is embedding itself into everyday technology, voice typing on your phone, spam filters, security cameras, those recommendation algorithms everywhere.
It's often invisible.
Right, working behind the scenes. You can choose not to use it actively for specific tasks, like writing an essay for school. And the source encourages doing things yourself for personal growth and learning.
Like choosing to walk for exercise instead of always taking the car.
Exactly. You have to consciously decide where to draw your own line in the silicon sand.
So if we can't avoid it entirely and we need to use it sometimes, what does responsible use look like based on this source?
The key advice is caution, especially with sensitive information. Don't share your deepest secrets with ChatGPT or other AI you wouldn't put on a public website. Think about data privacy.
Good rule of thumb.
Use AI for tasks it's good at, like summarizing long documents or finding specific information what the professor calls easy tasks, even if they might take a human a long time.
Things that are tedious but not critical judgment calls.
Exactly. But for high-stakes things, like drafting legal documents or giving medical advice, you absolutely need expert human review. AI is a tool, not a replacement for professional judgment.
Got it. Looking ahead then, what's the potential future of AI? Where could this take us, according to the Q&A?
Well, it holds immense promise, particularly in scientific discovery. AlphaFold, an AI developed by Google DeepMind, has revolutionized our ability to predict protein structures.
I've heard about that. It's huge for biology, right?
Absolutely. It's a fundamental problem in biology that used to take months or years of expensive lab work and now takes minutes. This opens doors to potential cures for diseases, improvements in general metabolic health, and accelerating research in countless fields.
So huge potential benefits.
Definitely. And AI will also continue to transform sectors heavily involving words, imagery, and video in the near term: content creation, media, marketing.
Makes sense. Finally, the Skynet question. How dangerous is AI itself? Is it going to decide to wipe us out?
The perspective offered here is that AI, as a tool without will or desire, isn't inherently dangerous in the way a villain from a movie might be. The danger comes from bad actors using this powerful tool for harmful purposes.
Like spreading misinformation, creating sophisticated scams.
It's exactly.
Right.
Or potentially developing autonomous weapons without proper human oversight. Skynet, that idea of an AI deciding to destroy humanity, is presented as a choice we as humans should consciously choose not to make.
So the danger is us misusing the tool.
Largely, yes. There are limited instances discussed where AI speed might be needed for things like defense systems, say intercepting missiles. But even there, the professor stresses that humans must retain control over the top-level policy decisions. AI shouldn't be making the ultimate call.
Right. Human oversight is key.
So we've really covered a lot here. From the historical roots and basic types of AI, to the surprising way it thinks using tokens, its current capabilities, and very real limitations in understanding the physical world.
The crucial issue of bias and resource use, its impact on jobs and how we use information, and these glimpses of its potential future benefits and dangers.
And the critical takeaway from this source seems to be that AI is an incredibly powerful tool. But it's essential to understand its fundamental nature, that it lacks human-like comprehension, will, or consciousness, and to be aware of its inherent biases derived from its training data.
Yeah, that literacy piece seems crucial.
Becoming AI literate, even if it's just getting that vague sense the professor mentioned, isn't just about keeping up with technology. It's becoming necessary for navigating the information landscape and participating in the future job market.
Okay, so as we wrap up this deep dive, let's maybe sit with that thought about AI potentially acting like a virtual Einstein, compressing millennia of research into seconds. If artificial intelligence can accelerate discovery to that unimaginable pace, what does that mean for the speed of human discovery and maybe our own fundamental role in seeking knowledge and understanding in the universe?
That's a fascinating question to keep asking, isn't it? What does it mean for us?
Absolutely. Well, that wraps up this deep dive into AI, pulling insights from the professor's expert Q&A. Hopefully this gave you a clearer picture and maybe some surprising new ways to think about the technology shaping our world.
Keep exploring, keep asking questions, and definitely keep thinking critically about the information you encounter wherever it comes from, human or AI.